Hello everyone, welcome to Learning Rail. In the diagram shown, M is the midpoint of PQ. The line PS bisects angle RPQ and intersects RQ, the line segment RQ, at point S. The line ST is parallel to PR and intersects PQ at point T. The length of PQ is 12 and the length of MT is 1. The angle SQT, this one, SQT, is 120 degrees. What is the length of SQ? No calculators were allowed and only about 3 minutes and 36 seconds were given to solve this problem. Can you solve it? Give it a try. Okay, so let's begin. So how are we going to approach this problem? First, let's just draw the triangle with its aspect. So we have SQT and we have the normal triangle. Now we know that PQ is 12, so let's label that. Because PQ is 12 and M is the midpoint of PQ, PM is 6. And we know that MT is already 1. If M, then MQ is also 6. And 6 minus 1, which is MT, it's gonna be 5. So TQ is 5. Now, because PM is 6 and MT is 1, we can add the two values to get PT, which is 7. Now, we know that PR and TS or ST and PR are parallel. So what can we do with that? We have these two angles, STQ and RPT, whatever. And so they both are congruent because they're corresponding angles from parallel lines. Now, the half of RPT, which is this part right here, that's going to be X. That way, this is 2X, which is STQ, because RPT, the angle, is bisected by the line PS. So, STQ is 2X. And then, if we want to find the supplement of this, meaning angle PTS, that's going to be 180 minus 2x. We know these two values, and which is x and 180 minus 2x. That way we can find out the value of the third angle, because we know that the sum of the angles in a triangle is 180. So if we add this angle, which is x, plus 180 minus 2x, plus whatever value you want to assign it, that thing, and they're all going to equal to 180. That way we can find that this value is also x. Because we have two congruent angles, we know that this is an isosceles triangle, and the opposite two sides of these angles must be congruent, meaning this 7, which is PT, must be congruent to TS. So we'll put that in. Now let's get rid of everything except the 7, 5, and 120 degrees. So this is now important because we might be able to solve this problem. There's a formula called the cosine formula, or the cos formula, which says c squared is equal to a squared plus b squared minus 2ab cos c. So c in this is side c, the length of side c, which is the longest side. A is one of the other two sides. B is the other side, and 2ab, which is basically multiply the smaller sides, the two small sides, cosine of angle C. That's why it's in capital. So angle C is the angle directly opposite to side C, so it's 120 degrees. Now we might be able to solve this problem. With this formula, plugging it in, we have 7 squared equals 5 squared plus t squared minus 2 times 5 times t times cosine of 120. We can simplify this further though. We can do the squares of everything. So we get 49 equals 25 plus t squared minus 10t times cos 120. Well, we know, and due to our cosine formulas, that cosine of 120 is equal to negative 1/2. That's why memorizing cosine values is very important, especially for an exam like this, because they might ask you about this. So, and remember, you can't use a calculator, so you'd have to memorize it. So negative 1/2, and now we'll plug it in again. 49 is equal to 25 plus 2t squared plus 5t. We can we can subtract from both sides 49, and we'll get t squared plus 5t minus 24 equals 0. We'll factor this equation to get t plus 8 times t minus 3 is equal to 0, and we get our two values for t. T equals negative 8 and 3. Well, if you remember what we're solving for as t, that's side s cubed. So, and it must be a positive length, because the length of a line segment or line cannot be negative. So t is not equal to negative 8. We can rule that out. It's an extraneous solution. Now we have t equals 3. That must be the right value. And that's it. Thank you for watching this video. Please make sure to like the video if you liked it. And please make sure to click the subscribe button and the notification bell icon to stay updated on the Learning Royal. Thank you.